Welcome to part 2 of the RAMview video series. This video is going to cover a more fleshed out RAMview example, and we'll see how to initialize RAMview inside Codesys using the supplied function blocks from the KEFEX library. We'll also look at reading and writing to EEPROM, as well as using the graphical interface in RAMview to see live data being communicated to the controller as we're logged into RAMview. The project I'll be using in this video is a little bit different than the part 1 project, but it's mainly the same. It has one list of RAM variables and one list of EEPROM variables. The difference you'll notice here in the RAM list is that one of these variables here is set as a function instead of a RAM variable. And what that means is that when a read or write occurs for this variable inside RAMview, it will trigger a callback function in Codesys. And you can set up that callback function to have whatever logic you need it to have to handle any of these variables that are going to be read or written to with RAMview. So other than that, the variables are just a little different, but it's all the same type of variables here. And the Codesys project already has the export file brought in, so we're ready to go. We have our Eeprom list here and our param list here. Here are the callback functions that were created for that output2 variable. And we can start going through PLC PRG to look at how things are set up here for this project. So if you notice, we have this first cycle if statement, and this will be, everything inside this if statement is what will happen the very first cycle that the controller runs. So everything down to this else here will be the first cycle code. Everything inside the else will be all the other cycles. So everything, every cycle that the controller runs after the first cycle, all of this code is going to happen in there. So we'll come back up here. This is pretty standard initialization stuff, nothing really related to KEFEX. So we'll come down here to this Initialized Kfx Driver. And we have this FB Kfx Init can function block here. And the first input here is an instance. And a lot of these KEFEX functions are going to use this, and it just needs the address of the structure, the global structure for the KEFEX server. And you can find this here in the KEFEX server data global function or global variable list. So it's a pointer, so we have to do the address of this global structure for the instance. After that, we'll just give it the bus number. We're going to be using CAN bus 2. And then here we have these 3 parameters. We have owner address, otherwise known as server address. We have client address, and we have the base ID. Now these will need to match the corresponding parameters inside RAMview, and I'll show you those here. So if we come back to RAMview, let me exit edit mode, go to communication protocol parameters. We have the same things here. We have base ID, client address, and server address. So in order to log in here and establish communication to the controller, you're going to need to make sure those two match, or those 3 parameters match what's set up here in Codesys. Next we have a function block for setting up just some information. If you want to, it's not necessary, but if you want to give Codesys information about your KEFEX application, you can do this here with like a name and version number. Next we have the KEFEX Init Callbacks function block. And this is where you will pass it the functions that were created here for reading and writing KEFEX values. Next we have load EEPROM. So we'll be reading EEPROM. And here again we pass the instance, same type of instance we passed before. And now it takes a list index. So this is defined globally. Again, we can browse, go to definition. So we have one of these definitions for our param list X and one of these definitions for EEPROM list X. We're going to use the one for EEPROM list X since this is the one of the list that we want to read right now. So this is the list index variable. And then we call the function, and it will pull data out of EEPROM and put it into the appropriate structure. It'll put it into the instance that we have for this structure. So once the EEPROM values are read, we can come down here and just set up the right EEPROM function block, because we're going to eventually be using that. So we'll just set it up here, but not call it yet. So I would give it the instance here. And again, we set up the list index, and it's using the same list index from the read EEPROM function block here. So it's the Eeprom list. So it's ready to be called, but we're not going to call it yet. Next thing that does is it checks the read EEPROM, and it says, did the read EEPROM function block execute okay with no errors? That's what this if statement's checking. If it's okay, then it's going to write something to the RS-232 port and everything is okay. Otherwise, if it failed with something like C_checksum, that would indicate that there was an error with the checksum values and the data is not valid. You could set defaults, and that is going to pull defaults from this group of variables here. Well, if we go to our EEPROM, we have this defaults here that were set in RAMview. So you can always fall back to these default values here. So we can set up our instance, set up our Eeprom list index, and then you'll give it the global handle for your defaults index, which again we can look here, browse to definition. And since we only had one set of index value or one set of default values in RAMview, it just has this one parameter here. So we're going to use this as our index for default values. Pass that in here, and then we would call set defaults, which would apply these default values into the Eeprom list, and then we would write those defaults into Eeprom to get some actual valid data back in there. And then here we're just checking the right Eeprom function block. If everything was okay, we print out something that indicates that. Otherwise, we'll print out something else here, default's not set. And you can do other logic in there if you need to handle your data. And the last thing here in the initialization section is we're just going to set up the KFX task function block, and that has to be called every cycle to keep things running smoothly with KFX. Okay, now we can move on to the cyclic section of the code. So this else statement contains the KFX part of the cyclic code. After the else statement, the rest of the program runs cyclically as well. So we have just an incremental counter, some standard project template things that don't really relate to KFX except this call to the KFX task here. So that's what's needed to run every cycle to maintain KFX in the project. Lastly, we have the ignition check. So this is the shutdown area. And what happens there is when we determine that ignition has been turned off, it's time to shut the controller down. So we write the Eeprom list here at shutdown, and then there's a small delay here, and we call the sysclose function block, which will safely power down the controller. So back up here to this else statement, we can see the rest of the KFX code that's going to run cyclically. And the first thing you see here is this if statement, and it's checking a counter value. And based on the task time of 10 milliseconds, this if statement will allow the code inside to run once a second. So every second, this variable, this total runtime variable from the Eeprom list is going to be updated and incremented by 1. Next, we have this ADC value function block, and it's just getting the value of the ADC channel. And if we go back up to the initialization area, we can see that it's using what's basically battery voltage input to the controller. So it's checking that, getting the value, and this if statement is going to update the value of output 1 to input 1 scaled from 0 to 10,000 essentially. So really what's happening here is it's checking the override value of the param list x. If it's 0, it's going to use these internal values to scale output 1. If it is not 0, it's going to use the output 1 override value from the param list x, and it'll write that to output 1. I'm going to skip this for now, we'll come back to it. And then lastly here we'll see that the internal input 1, input 2, and output 1 variables are being written to these KFX input 1, input 2, and output 1 variables. So that's how RAMview will get the values of these controller values, and we'll be able to log in and see those values in real time. So now if I go over to RAMview, I can log in, I can make sure that my protocol parameters match the KFX login parameters. And next, I'll just do communication, log in, make sure the controller's on. And you see here the light turns yellow now that I'm online. And so we have this control panel over here, and I can read the list, this RAM list, with this button here. And it'll use whatever setting we have configured here. So you can read it once, or you can do a time-triggered read or event-triggered. We have it set for time-triggered here, and it's going to read every 1,000 milliseconds. So when you click read, it'll start cyclically reading the values. You can stop the read. You can write to the whole list, so you can change all these values, whatever ones have write access anyway. And then you can click write, and it'll change write all the values to the list. You have write changed, which will only write values that are different than what the original value was. You can write default values based on what you have configured for your defaults here. And then there's also a compare function. You also have read and write controls for single values. So if you highlight a value and you change the value, you can do a write here or read back the value. There's also a charting functionality where you can bring in your variables here and see a chart of the changing values there. So for this RAM list, what I'll do is I'll click read, and it's going to be time triggered, so you'll see these green arrows showing that it's cyclically reading. And we have input values to the controller, output values to the controller, and what we're going to be looking at here is this output 1. So if we go back to the 3CM code, you'll see that if the KFX variable for output 1 override is off, it's going to use this internal scaling value from 0 to 10,000 as the value for output 1. If I enable the output 1 override, we're going to use the override value from KFX RAMview, or whatever is given here in the code. So we'll see what happens when I change this override value. We'll see what happens to the output 1 variable here. And again, remember, output 1 is getting written to the output 1 param list X value. So output 1 override is off, so the value of output 1 is now based on whatever is happening on the input to the controller. So here I'm turning the input on the controller down, and I'm turning it back up, so I have control over that value. Now what I'll do is I will give the override value a non-zero, let's say 5,000, and I have to stop reading the list first, otherwise it'll keep updating. So now I can give it a value of 5,000, and I'll set the override to 1 to activate it. I will click write. Let's try write change, so it'll just write the values that changed. So now these are the new values that the controller is using because it's in constant communication with RAMview. And now I can read again, and what should happen is this output 1 value should no longer be tied to the input to the controller. It should be overwritten with whatever I have set here. So if I do read, you'll see that it now is stuck at 5,000, and no matter what I'm doing on the input to the controller, it doesn't change. So that is what's happening in this line of code. It's using the override value to update the output 1 value from the controller, which is being copied to the param list X KFX variable, and that's how I'm able to see it over here in RAMview. Next, we have this Eeprom list, and I can go to Eeprom, read the values, and you'll see this total runtime value. Now, what's happening here is when I read from Eeprom, it's reading whatever was stored in Eeprom when the controller was booted, or the last time it was written to. So the last time it was read from, is when the controller was booted very recently before we came here into this example. So it had a value of 8,099. If I go to RAM, this total runtime value should be much higher because the code is continually updating the total runtime value here, incrementing it by 1 every second. So I can do a cyclic read here, and we can see that every second it's incrementing by 1. So what I'll do now is I will turn the controller off using the ignition pin, which will trigger this code to run, and it will trigger this EEPROM, write EEPROM list function block to execute, which will store the values, the RAM values that this list is working with, and it'll store it into EEPROM so that the next time we load, I can see these updated values. So let's watch this. Let me stop here. Let me log off. And remember the last, here I'll show you what the last EEPROM value was. We had 8,099, and we're up here now in the 9,000 range. So when I turn the controller off and turn it back on, this value should be stored. Turn the controller off. I should write to EEPROM. Now I can turn the controller back on. Go back to EEPROM, log in, and read, and now we have a 9,000 value stored in EEPROM because the shutdown cycle took the values that were in RAM, stored it in EEPROM. When I turn the controller back on, it read from EEPROM, and it put those values in RAM to continue working with. Lastly, I'll go over this if statement that I initially skipped, and this is dealing with the function type variable from RAMview from the param list X. So if we look at edit mode, we'll see that output 2 was a function type variable. So every time this is read from or written to, it's going to trigger a callback in KEFEX on the controller. And we created these two functions, these callback functions, to handle that. And up here in the initialization code, if you remember, we set up this KEFEX Init Callbacks function block and told it which functions we were going to use for the read and write callbacks. So every time a KEFEX read happens for output 2, it's going to call this function here. Every time a write value, or every time a write command happens for the output 2 variable, this write value function is going to execute as the callback. And what they do, I'll show you real quick. It's basically checking the value to make sure that it was the output 2 variable that changed. So it's saying, was the list index param list X? If so, was the variable index output 2? If so, then we're going to update our value here for output 2. The write value is a very similar thing. It's checking, was it param list X that the value came in on? If so, was it output 2? If so, then we're going to do some logic here for this variable. So keep in mind that whatever variables are set as function types in RAMview, they are not editable in Codesys. They're only editable from RAMview. So these are basically just flags that tell the controller that something's changed, and it gives you a chance to react to them. So those function type variables are not something that you can edit and change on the fly. They have to be read from or written to in RAMview, and then you can use these callbacks to react to those changes. Back in RAMview, one last thing to note about EEPROM values is that if you overwrite an EEPROM value in RAMview, and then your code in Codesys writes to that value with some value from its own internal variables, whatever you write here in RAMview isn't going to get saved because Codesys will have the last say when shutdown occurs. So let me show you what I mean here. Let me start reading this. Here, I'll read the EEPROM list here, but I'll look at the active current value, the RAM values. So this 9500 value is what's currently in the total runtime. If I look at EEPROM, it loaded with a 9100 value. So I can come in and I can say, I'm going to change this to, let's say, 10,500. and I'm going to write that value. Okay, so now that is stored in EEPROM. But when I log out of here and I shut down the controller, it's going to write whatever it had previously in RAM right here. So this is its working values that it's going to write. It's going to use this function block to write whatever it was working with at the time here, and it'll overwrite anything that you used in RAMview. So when I turn the controller back on and I log back in, I can look at my EEPROM and read, and we're back at 9500. So just keep that in mind, that when you write something to EEPROM in RAMview and you want that to stick, you should also change the RAM value. Otherwise, your controller code could very well overwrite it if you're writing to EEPROM on shutdown. Well, this concludes the RAMview video series. Please be sure to check out our other videos, and thanks for watching.